My name is Mike Lyon, and I'm in product management Scale. For the past couple of years, I've been really focusing on our edge computing and service provider market. And really the biggest thing I've been trying to figure out, and we've been trying to figure out, the problem we're solving is reconciling the concept of keeping, really simplicity and ease of use. That's in our core fabric. That's the core part of our product. And how do we reconcile that concept with edge scale infrastructure when you have tens, hundreds, or thousands of sites? How do you manage those easily? How do you, in a consistent manner with a single pane of glass without having to worry about managing thousands of individual endpoints? How do you put that into one platform so you wind up with really a simple, easy-to-use platform regardless of whether it's 10 sites, 100 sites, or 1,000 sites? And even going beyond the monitoring capabilities, trying to figure out how do we actually go into orchestration and how do we take advantage of what we can do at the edge with our infrastructure and add on products and add on components really that make it easy for you to orchestrate and manage your infrastructure. And as we were trying to solve the problem or figure out exactly what it was that the edge is going to need, we were working with some of our larger edge deployments to get feedback from them. And really they were talking about initially the care and feeding of their gear at the core and at the edge. How do they unify the management of getting reporting and getting monitoring all under one single pane of glass without having separate components, separate vendors, another API to call on. And we really wanted to build something that was extensible, that was easy to develop against, that we could even provide endpoints within our API so that if there's other customizations or if there's anything specific that we didn't provide out of the box for you, you would have a platform that was easy to hook into. And then the data that we're looking at, especially again, when you think about edge scale with hundreds or thousands of sites, the data going back and forth, even just of analytics and updates, that has to be lightweight and it has to not affect and impact the core resources or the resource that you have at the edge, which are going to be fairly minimal as it is. You don't want to be using additional resources and additional overhead just to do updates, just to send pings and your basic what's up, what's down. So you really have to have an update-only, low-overhead approach to that.
Mike, you don't put on that slide anything about security. I'd have thought the security of...
That's I've talked about that in the next slide, but yeah, security is obviously paramount for that.
Yeah.
And because along with, we've got different input vectors, there's also threat vectors there as well. But taking the data from your network stack, from your infrastructure stack, all those different data points that are relevant to the operation of your applications, how are things performing. That's a deluge of data that's coming in from thousands of endpoints and sites. And how do you manage that in a sane fashion? And really, it requires absolute simplicity. And again, that's really a core part of our product is having a simple, easy-to-use user interface to deploy everything, to manage your cluster, and we really wanted to take that same functionality and extend it out to hundreds or thousands of sites. So what's the problem that we're trying to solve? There's different consoles for all kinds of different management endpoints, whether it's from your network, whether it's from your backup, whether it's from your orchestration deployment. You've got consistency. Do you have the right amount of data? Are you storing too much? Where is that data going and who's doing anything with it? Are there decisions being made or are you just collecting data and storing it? Which we find is common. And you've got the four silos really of infrastructure management and then inventory management going into the guest. And if you look historically, there was separate tools for that. And even today we've got your basic SolarWinds type tools just to manage IP addresses, to manage your VMs. And then at the network layer, you've got network statistics, and that's obviously vital again at the edge as we're dealing with tracking latency. And when you have separate data silos, you've got all those data pools separated. What are you going to do with it? Do you have a way to evaluate it, to analyze it, to take action on it? And then taking the next step, really going beyond management and going into monitoring or orchestration. Because at the end of the day, if you have a collection of looking glass tools, even if you're familiar with them and you don't mind checking them in different places, that's still giving you a read-only view, if you will. And that's where thinking about the initial deployment of thousands of clusters in a simple fashion, that's where having a single tool to do that is really pretty vital and required.
I want to give you a prize there for talking about OpenView. That's the first time I've seen OpenView in a decade.
All right. I was wondering if anyone
know
would
that
see that
was
or Unisetter.
I mean, like, honestly? Really?
Yeah, I'm an old ATM friend relay guy, so I use it a lot.
Out.
All right. And if we look at the previous slide, we thought about those 4 silos and where we're getting the information from. Really, it comes down to having to make decisions about the data that we get. And again, this is at the edge scale when you have dozens to hundreds to thousands of sites. That's a lot of data coming at you at once. And there's some of that that's going to be actionable and worth looking at. But if you have those separate data management pools, are you actually getting the data that you need? And if you think about the OODA loop, it really is applicable to a lot of places, but especially in infrastructure management, even more so in the edge, because we have to be able to do things without necessarily being on site or even having resources on site. So we're heavily dependent on the data that we get remotely. And as the infrastructure has really changed and adapted for the edge marketplace, that's really pushed a big need for us to depend on how are we getting that data reliably from those remote sites. And it's all going to be very distributed, so you have to have a way to aggregate it and get it into a cohesive and easy to consume view without having an effect again on the underlying transport, affecting security, or affecting the overhead just of running your VMs. Again, in edge deployments where you're not going to have necessarily the space or the overhead to run a dedicated monitoring VM at that site, and we really have to keep that footprint as low as possible. And then over time, it doesn't matter. Again, as you grow your deployment and as that scales up, the amount of data you're getting and the rate at which you're getting that data, streamed at you from those different directions is really only going to increase. I'd love to say exponentially, but I couldn't necessarily prove that. So in the previous slide, we talked about a heavy reliance on multiple data sources, and that's really one of the challenges that one of our edge customers was presenting us with is, we've got, they're the same console, but we have to go and get the data from hundreds of sites. How do we get, the data from multiple sources into one spot? And that was, again, building a platform that has one interface rather than having to go and gather that data ourselves to do something about it. And that data has to be, again, captured, put together, and managed and dealt with regardless of whether it's 10 or 100 or 1,000 sites. And it has to be, give you something that's informative, that's actually data you can do something with without relying on a script or an algorithm or a human to actually get involved and say, okay, I need to take action here. We need to give it to you in a way that you can see there's something that needs to be done. And also that comes down to filtering it out to the most relevant data that you're going to be seeing. Orienting what you're consuming based on edge infrastructure, getting rid of spurious data that doesn't matter, not necessarily getting rid of it, but still leaving it there so you can consume it in an API if you want to. But
see, what you're saying here is that the telemetry, I'm thinking of a 3-node system like you've laid out here, as you've laid out in the opening sequence, and then here. How much telemetry data would come off that? I can't imagine that it's gigabytes or,
Not a whole lot, especially from the way we've, and I can show you in our console, we're really using HTTPS and it's just sending very small updates across the wire. So it's really just a delta of, the resources that changed from the previous pass. Right. So it's pretty lightweight. Yep. Now again, as that scales up, that could be, maybe a terabyte of data depending, but it's really fairly lightweight. Yeah. But again, a lot of that's going to depend on how long you want to keep that data for. So the retention.
Petrol stations with 64K lines out there, so.
Yeah. So everyone wants that holy grail of a single pane of glass. But what we were trying to reconcile that problem of simplicity and edge infrastructure. And really what it made the most sense to do was to put in and build together an orchestration platform. So you can run, compose, going through the whole VM lifecycle, not just monitoring, but application lifecycle, getting performance metrics, automation around behavior for node failure, all the way down to if you want to get a node, alerted on statistics exceeding a threshold. And that's all going to be in one console, not just having your OpenView or your looking glass for network stats, and then having a separate, I've got a script book for Ansible playbooks, putting those all together into one single platform. So what we did, we built everything around our REST API. So beyond our core platform that I'll show in a little bit, we do have a very robust API. And in keeping the idea of keeping it easy to use, the documentation's built into the product. You can generate code examples even by actions you specifically want to do. So whether it's that initial cluster configuration or deploying VMs or DR orchestration, it's very easy to do and it's very easy to use. So we've got endpoints for just beyond just the basic VM lifecycle management or CRUD. Anything you can do in the user interface is mapped to an API call. Specific use cases really are for DevOps. If you've got a significant amount of VM turnover and you've got life cycles for testing or development silos. It's also a way that I first started using it to get optics, and I wanted to get custom graphs that we didn't have at the time on disk latency. So I was able to just query and graph that and feed that into, actually at the time I was using Kibana, but really any format that'll consume JSON, shove that to a time series database and graph it. And then configuration and deployment automation. So it's easy enough to script that up and use our REST API to do that. If you didn't want to, we have other ways to tackle that. But really that going from the packaging to the production point, as I say, how do I get it out of the box to production ready with workloads on it without having to spend hours configuring, spend hours setting up, that this should just be pull down and config and go. And again, talking about having everything we can do in the user interface available as an endpoint in the API.
So what are customers typically doing then? Are they pushing configs and not changing anything, so leaving it sort of read-only? Or if they do change something, do they have to pull the config back so that if you have to rebuild that environment, you can push it again?
The configs are all mostly pulled, so that you would generate and have a static configuration that would then get consumed at that remote node or site.
Right, so rather than change anything on the target device, you change the config in.
Correct, central.
And then just push it back out again.
Yeah, wherever that central host would be. And what the API does allow you to do is to get really specific analytics. If there's anything that we don't have graphed today with our UI, this is a great way to get specific visualizations. If there's something that's not available, or even if you wanted to expose it, this is a great way to graph and get specific utilization metrics.
So just a question, you're mentioning VMs and being able to pull these configs. And you guys package all that up, and you package certain applications up, it sounds like, too. So do you use containers, or do you have a specific orchestration tool you use if you use containers?
So our orchestration tool that we use and that we built in is Ansible. So it's
what?
Ansible.
Okay.
Now this can run as a container, but we aren't providing necessarily we aren't providing a Kubernetes platform or a container orchestration. But we're giving you both through the API and what I'm going to show you shortly, we're giving you a way to automate that. So what our first iteration really was a multi-cluster management platform, which was just, again, a looking glass. So this took the remote sites data and provided them in a single user interface, which, again, is nice without having to log in and get that data from hundreds or thousands of sites. We got a lot of feedback from our larger edge customers. So they really wanted to get one place, one canonical source of data to go to, or even provide a specific view for other customers. So if they wanted to create custom views, group their data, it's a fairly easy to use and extensible platform. But we wanted to go to the next step and say, okay, outside of just monitoring, which is great, we can drill down stats based on utilization, based on any number of metrics. But again, how do we get to the holy grail of orchestration and monitoring and management? And again, to provide this platform just at a high level, this can run as a Docker container. It's very lightweight. It's got a small database. And that's really, the persistent storage for that is really going to be your biggest challenge. But at this point, 10 gigs would probably be enough for a while. Or it can just run as a VM. But it's very lightweight. And in spite of that, we were able to integrate in actual orchestration. So using Ansible and allowing you to deploy playbooks to remote sites or groups of sites or groups of clusters without having to create a special filter view or without having to use something like Ansible Tower, which is licensed from Red Hat, and that's a not inexpensive option. This is giving you a really truly orchestration platform it's simple and it's easy to use, but you don't have to really understand how am I going to create a domain to manage multiple sites with Ansible. You can upload and deploy those playbooks and execute those really in a single user interface and even see the progress of those, which is something that doesn't exist out there in the Edge marketplace today. And yeah, talking about be able to execute the playbooks from within the central ARPANET instance, and ARPANET's our project name for it. But you can also have different views. So if you wanted to have different roles, able to see different clusters and execute against those, you can even compartmentalize and go down that way. And the other important part was this was a great way for us to build a central database and a central repository of basically all the Edge sites. And that became the canonical database that we're able to use. So it's great for managing, thousands of sites, but realistically, in the dozens to hundreds, that's where it's going to be worthwhile to have a tool that allows you to do this. And not just onboarding, and not just bringing in VMs, but really the entire life cycle of maintenance of your infrastructure, not just the VMs as well. So now let's see it in action. That's the best part anyway. All right, so there's going to be a few windows, and I apologize for the cluttered nature of it. But what I really want to show you is we're going to kick off an Ansible script from our user interface, and it's going to deploy 3 VMs that have a web server to this cluster in the HQ. Add those to an HA proxy, and we'll show how we can get to those when that's done. It's going to add a web server role to it, so it's going to take a basic stock CentOS VM, do some things to it, update the firewall. And then again, provide an app server or a web server. And then on the second cluster, we're going to deploy 4 app servers. And we'll be able to watch the progress as that goes when it's done. So I'll keep this, this will be your HA proxy. The VMs will show up there when they're deployed. And then they'll start to populate down here. But this is the multi-cluster view before I run it. In this case, I only have 4 clusters, but really I'm able to get an at-a-glance look of their statistics. I can sort by utilization. By default, it's sorted by criticality, so clusters that need you to take action are going to show up at the top. You can also create filters, which are groups. Again, these can be grouped by whatever is going to make sense to you, however it's going to be logically organized. But it's grouped by name, and from within the group, we can see individual job status and deploy them. So I'm going to kick off our store infrastructure job. Yeah, I'm going to resize this, so in just a minute we'll see. It's going to connect and start creating the VMs on the clusters. Again, this is all just using Ansible playbooks that can be uploaded, and it's easy enough to specify it to a single group or an individual node in a remote site.
Mike, it seems that would get a bit cluttered with 1,000 clusters, or even 100 or 200, or is there a way to
this view
down?
All of it.
Oh, to collapse down the view?
Yeah, because if you had more than, say, 50 or 100, scrolling to
that was some of the better feedback we got from Delhaize in Europe, was they wanted to have a list view. So that's an iteration coming.
Okay.
So the web servers are being installed right now. I don't have the Ansible console up, but basically it's the next thing it's going to do is install Apache and then update the firewall. But I can look at my jobs here. And it'll show us the progress of the deployment on those individual clusters. So even though I only ran and actually executed the job on one cluster, that specific Ansible playbook is taking action on multiple clusters. That'll going to get reflected up there.
And so when you say that you guys provide different applications for some customers, right? What is that? Is that like that LAMP stack, or like what kind of application?
Well, this is this would be an application that we would provide, and
okay.
It's not we would deliver it really as a product, but it can run as a VM, but it's not a specific application.
Okay, gotcha.
And the progress in being able to see actually what's going on in your Ansible deployments is really something that has been productized. Again, Red Hat has it with Ansible Tower, and that's 15 grand, I think, for the first 100 nodes. And that's really all it's doing is it's giving you a UI that allows you to see how are my jobs being deployed and allows you to create views to deploy multiple jobs. But that seemed like an exorbitant price for something that really, again, this is fundamental to having a management platform for edge scale infrastructure. So it's doing the app servers. The next step is it'll validate that they're up. In this case, we just put in an SSH checkpoint, but it's almost as exciting as watching Windows install, right?
So I wouldn't have to use the GUI if I didn't want to. I could just do all of this through APIs.
Yes. Yeah.
So the fact that I said that that dashboard looks like it would get difficult, I could just leave that and just go off and
Yeah, if you wanted to use your
write
own,
something
sure.
separate. Yeah.
Yeah. So we've moved on to step 5. It's doing a last-minute validation. In an Ansible, a completed task is yellow. So I figured we should maintain that also color when the status bar completed. Initially, I couldn't figure out why it wasn't green, but Ansible's completed state is yellow.
That sounds like Ansible. Do it the wrong way for it to be right. Yep.
Yeah, that'll
Yes.
integrate nicely with all the other ops tools.
Yep.
Yeah.
So they just finished up. They're yellow, which means we're done. So those web servers here, again, they registered an HA proxy. Or I can also go directly to one of those VMs that was created. Let's see, 195.
So the real power here is the fact that you've created these virtual machines and the storage engine that sits under them that's just really tight and efficient.
Yeah, and being able to leverage a central monitor or a centralized way to actually kick out and do those deployments.
So for 3, 10, 20 of these
Right.
of your members of a cluster, but it's all very tight and efficient. It's not bloviated like VMware, which just gets rapidly out of control.
Right.
But the flip side is they've got 1,000 knobs and levers and buttons and things.
Yeah, so the API really is the best exposure of all those nerd knobs that we don't have. And honestly, it's like I said, I was using it to get VM stats, actually VSD, our virtual disk latency, because that's an easy way to get it. And it's all there, but yeah, those are the easiest nerd knobs to get at.
Right.